Hi guys, and welcome back to Maths with Cats. So in today's video we're going to be going over composite and inverse functions for AQA A-Level Maths. So the basics we'll go over first. A function is an operation that maps one number onto another number. Each number is only mapped onto one number. A function can be written in two ways. F of x equals x squared and f colon x arrow x squared both represent the x squared function. The set of numbers that can be put into the function, x values, is called the domain. The set of values that come out of the function, the values of f of x, is called the range. The domain and/or range is usually the set of real numbers R. If x can be any real number, the domain can be written x, I said E-R, I don't actually know what this sounds called, but I go E. In a one-to-one function, each input produces an unique output. In a many-to-one function, there are multiple inputs that produce the same output. In a one-to-many mapping, one input can give multiple outputs, but by definition cannot be a function, because for it to be a function, each number is only mapped onto one number. Composite functions. So this is when you take two functions and combine them by using one and then the other, and it allows you to make another function. So the function which represents the first function being applied, then the second function being applied, is called the composite function. So f of g of x is an example of a composite function. In this example, you work out g of x and you use this is the output for f of x. So you can think of it as f of big brackets g of x. So the way I process this is you're putting g of x into f of x. Usually f of g of x is not equal to g of f of x. F squared of x is the same as f of x. So here's some examples. For f of x equals 2x cubed, where x er, and g of x equals x minus 3, where x er, find a f of g of 4. So we'll do that one first. So g of 4, to work that out, you replace all the x's with 4's. So you get 4 minus 3, and 4 minus 3, real easy, 1. We want f of g of 4, so we're going to put g of 4 into f of x now. So that means we're going to replace all the x's in f of x with g of 4, and we know g of 4 is 1, so we're going to replace all the x's in f of x with 1, which is 2 lots of 1 cubed, which is 2. So that's the answer for 1. For A. B is asking us to find g of f of 4. So f of 4, we were going to replace all the x's with 4. So 2 lots of 4 cubed, and that's 128. But we want to find what you get when you put f of 4 into g of x. So g of f of 4 is g of 128, because f of 4 is equal to 128. 128 minus 3 is 125. Number C. So this is basically asking what is the composite function. So remember, you're putting g of x into f of x here. So g of x is x minus 3. So to put that into f of x, we're going to replace all the x's in f of x with x minus 3. So that leaves us with 2 lots of x minus 3 all cubed, like this. You could expand it, but you don't need to. That is a perfectly suitable way to write the function. And the last one, D, is f squared of x. So f of x is 2x cubed. F squared of x is the same as f of x. So what we're going to do is we're going to replace all the x's in f of x with 2x cubed. So we're going to have 2 lots of 2x cubed, which is 2 lots of 8x to the 9, which is 16x to the 9. Here's some more examples. For f of x is equal to the square root of x, and where x is more than or equal to 0, and g of x is equal to 1 over x minus 1, where x is more than 1. Solve f of g of x equals a half and state the range of f of g of x, giving your answer in set notation. So, first thing we're going to do, if g of x is 1 over x minus 1, and that means that f of g of x, well, to do that, we're going to replace all the x's in f of x with g of x, or 1 over x minus 1. So we're going to end up with the square root of 1 over x minus 1. That is what f of g of x is. We're going to solve that equal to a half. So 1 half equals the square root of 1 over x minus 1. You can square both sides. You get 1 over x minus 1 is equal to a quarter. You can then times up by 4 and x minus 1. You can do that in 2 steps. I do it in 1 step because I found it easier. So you get 4 is equal to x minus 1. Move the 1 to the other side, you get 5 is equal to x. Now it wants us to find the range of f of g of x. So as f of g of x is a square root, f of g of x has to be more than or equal to 1. Underneath that square root is 1 over x minus 1. That can never be equal to 0 because the numerator is never going to be 0 and the denominator can never be 0. So this is never equal to 0. So we can get rid of the equal part and the range would be f of g of x is more than 0. It wants it in set notation, so we have to write it like this. So use the curly brackets. F of g of x colon f of g of x is more than 0. And then another curly bracket. Okay, so the next thing to cover is inverse functions. So an inverse function does the opposite to the original function. So for a function f of x, the inverse is written as f to the minus 1 of x. Inverse functions map the output onto the input. So if you put 1 into f of x, it will give you an output. If you put that output into f of minus 1 of x, or the inverse f function, you will get 1 out. Only one-to-one functions have inverse functions, otherwise it would not be a function by definition. Because if you did a many-to-one function or a one-to-many function, either the original one isn't a function or the inverse isn't a function. F of minus 1 of f of x, or the inverse f of x, is equal to x, and that is the same if you do f of minus 1 of x. The domain of the inverse is the range of the function, so you just switch them. Inverse is the range is the inverse. The domain is the range is the domain. Examples. Find the inverse of the function f of x equals 3x squared plus 2 with domain x is more than or equal to 0 and state its domain and range. So, first, let y equal 3x squared plus 2. You'll leave it as f of x, it's just a little bit easier to rearrange it this way. So we want to rearrange it to get x as the, what's it called? The subject, that's the one. So we'll minus 2 on both sides to get y minus 2 equals 3x squared. Divide by 3 to get y minus 2 over 3 equals x squared. Square root to get the square root of y minus 2 over 3 equals x. Because it gives us that x is more than or equal to 0, we don't need to consider a negative root. So f of minus 1 of x is equal to the square root of x minus 2 over 3. So all you do for the last step is switch the x and the y and then replace the y with f minus 1 of x. as the domain of f of x was x is more than or equal to 0, the range of f of x is f of x is more than or equal to 2. The range of f minus 1 of x is f of minus 1 of x is more than or equal to 0. And the domain of f of minus 1 of x is x is more than or equal to 2. Yeah, so you can see here, these were given in the, well, you could work, so, what was I going to say? So the domain was given in the question for the original one. The range could be worked out, because if x has to be more than or equal to 0, the smallest x can be is 0. Sub 0 in there, you get 3. The range of inverse then is the domain of the original, and the domain of the inverse is the range of the original. So that's that question. Okay, here's another example. I think this is the last one. Sketch the graph of the inverse function of f of x equals x squared minus 8 with the domain x is more than or equal to 0. So from the domain of f of x, you can see that the range of f of x is f of x is more than or equal to minus 8, because if you stub in 0, you get minus 8. Let y equal x squared minus 8. So this would mean that y plus 8 is equal to x squared, which would mean the square root of y plus 8 equals x. Once again, as x is more than or equal to 0, we don't have to consider the negative root. So f to the minus 1 of x is the square root of x plus 8, and from f of x, we know that the range of the inverse function of x is f to the minus 1 of x is more than or equal to 0, and the domain is x is more than or equal to minus 8. So this produces this graph. I'm not going to go over it in too much detail how you decide that's what the graph looks like, because there's another video I've done very recently which explains that in itself. Okay, I hope you found this video useful. If you've got any feedback for me, leave it in the comments below. I always find it useful to know how I can improve. Like, share, subscribe, do whatever, and I will see you in a future video. Bye guys!